Let's say that you're looking for a way to connect a new data source to your Pi system, the data from this truck, for example. You might have heard of the term Pi connector as a possible option. But for other data sources, you've been using Pi interfaces to collect the data. So what exactly are these Pi connectors? They're a new line of applications which, like Pi interfaces, collect data from a data source and send it to the Pi system, where it becomes available for you and your users. Pi connectors are designed to scan a data source periodically, and then send the data they find to the Pi system. They can even automatically send new data. For example, if this truck gets a new data stream, it could automatically be collected. And if you add a new truck to your fleet, when the new truck's data starts appearing on your data source, it could also be collected. Pi connectors make it easy to deploy and manage data collection for large evolving datasets. So what's the difference between a Pi interface and a Pi connector? First, Pi interfaces don't automatically discover data on a data source. When you first set up your Pi interface, you need to create a Pi point for each stream of data you want to store. And whenever you want to add a new stream of data, you have to manually create and configure a new Pi point. For Pi connectors, when you first connect them to a data source, they will automatically discover all the data available. You, as the administrator, can then choose the data you want to store. The Pi connector will then create the Pi points, elements, and attributes needed to store all the data you've decided to collect. If new data streams are added to your data source, these can automatically be collected by the Pi connector. This can be especially useful if new data is often added at the source. For example, if you're monitoring a fleet of trucks, and data from new trucks are constantly being added to your data source, the data from these new trucks can automatically be collected. Other configuration steps are also streamlined. For instance, while buffering needs to be configured manually for Pi interfaces, Pi connectors have an automatic built-in buffering mechanism. The type of data that can be collected is also different. Pi interfaces can only collect time series data, which is sent to a list of Pi points on the Pi data archive. Pi connectors can collect both time series and metadata. This is data that doesn't necessarily change with time, but provides additional context about your data. Back in our truck example, the data source might have information about the manufacturer or the last date of maintenance. The time series data is saved to Pi points on the Pi data archive, and the metadata is saved to elements, attributes, and sometimes even event frames on the Pi asset framework. Alright, now that we've compared the two, let's summarize the advantages of Pi connectors. They're easy to configure. Configuration and management is done through a web interface that you can use to access your Pi connectors from any machine. They automatically discover data on the data source, and they automatically create Pi points in the Pi system. You simply connect to your data source and let it do the rest. They send data faster. Their throughput can be up to 10 times higher. And finally, they're more secure. Pi connectors are built on a modern software platform with a strong focus on security. So when should you use a Pi connector? They could be a good fit for a couple scenarios. First, if you're collecting from a brand new data source. There is currently no way to migrate data from a Pi interface to a Pi connector. If you're collecting from a data source on which new data streams are often added, and if the data source contains metadata that you want to collect, like in our truck example. It's important to keep in mind that Pi connectors are not a magical solution for creating models of your assets in the Pi asset framework. They simply replicate whatever is on the data source. You will still need to put time and energy to leverage the functionalities of the Pi asset framework. Finally, they're a great resource for security-conscious organizations. If your data collection scenario sounds like a good fit, it's time to check if a Pi connector exists for your data source. All the currently released Pi connectors can be found in our Pi System Roadmap on the TechSport website. To get there, click on Pi System Roadmap under Resources. Then scroll down to Pi Interfaces and Pi Connectors. We have the Pi Connector for UFL, which collects data from JSON, XML, CSV, text, and other ASCII file formats. It can even listen for data on a REST web service endpoint. We have Pi connectors for standard communication protocols like BACnet, Heart IP, and Ethernet IP. Finally, we also have Pi connectors for systems like the Wonderware Historian, which you can use to import rich metadata from the source. This page lists the tentative schedule and product functionalities planned for upcoming releases. You can also use our Pi Interfaces and Pi Connectors product page to check if a Pi connector exists for your data source. Navigate to Products, then Interfaces and Connectors. Then simply type your data source in the search box. Finally, if you want to provide feedback to our Pi Connectors development team, we encourage you to join a Pi Connectors beta program on Pi Square. We typically host these programs for Pi Connectors with a highly anticipated release. You can find these under All Things Pi, and then Pi Beta Programs. The active beta programs will be on the main page. Joining the program gives you access to beta software, which you can evaluate in your test environment and then send your feedback to betaconnectors@osisoft.com. We're constantly looking to make data collection easier, faster, and safer, so you can focus on what you do best, making the most out of your data.